Okay, we tend to use axial and equatorial in the context of trigonal bipyramidal. Okay, so trigonal bipyramidal, I guess we all know what's trigonal. If I give an example, PCl5, say for instance, phosphorus, and then we have chlorine, right? And another one is obviously uh, like now there are three, we know there are five chlorine atoms, isn't it? So phosphorus is the central atom, and out of those five chlorine atoms, three of them will have equatorial positions. Three chlorine atoms will occupy equatorial positions of 120-degree, like all of them will be 120-degree apart. Like, do you get it? Like all of the three chlorine atoms will be 120-degree of each other, and the rest two will occupy axial positions. Okay, axial basically means above and below the plane. Like, let's say for instance this is a plane, all right? So axial positions are basically if something is present above the plane, if something is present below the plane. So you can consider phosphorus as a plane here. Like for instance, it is present in a horizontal plane. So two chlorine atoms will occupy axial positions of 90 degrees apart to each other. Am I clear? Sorry, not 90 degrees, 180 degrees. So, Rakshit, are you understanding? So, these two are axial positions. Did you get it? Okay. And what's equatorial? Now, this is now obviously the rest three. One will be like this here, and another will be somewhere here. Okay, and the other one will be, let's say, somewhere here. So I think you can understand this, right? 120 degrees, that's 120 degrees, okay? And that is 120 degrees. Okay, so all of these three, like three of these chlorine atoms are present where? They're present in the plane where the phosphorus atom is present. But the two chlorine atoms, they're in the axial position, meaning they're basically in a plane which is kind of perpendicular to the plane of where phosphorus is present. Am I clear? Like in this plane. So these three are known as, where they're present, are known as equatorial position. Okay, do you understand what is axial and what is equatorial? I mean, this is 180 degrees. I think you can understand the whole thing, right? Okay, Rakshit, did you understand? Okay, I think you understood. Let's move on to the next one. You had an issue with January 25, question number 13 and 17, I believe, right? Oh, okay. So question number 13, I can clearly see it is related to the concept a little while ago that I explained, isn't it? Like this one. Uh, okay. Now, can you solve this? Like, do you understand what? I think you had issue with understanding the meaning behind Excel and tutorial, right? Is it? Yeah. Okay. 1 minute. Okay, first of all, well, we need to see one thing here. Like, what do we know about permanent dipoles? So, if a molecule is, let's say, symmetrical, if it's symmetrical, I mean, if it's not symmetrical, then it must have a dipole. I mean, that's what we know, right? And if it's asymmetrical, then, I mean, if it's not symmetrical, basically asymmetrical, then it must have a dipole. But if it's symmetrical, then it should not have a dipole. Am I clear? I mean, we know this, right, Rakshit? Asymmetrical, so this will obviously lead to, having a dipole, and symmetrical molecules won't have a no dipole. All right, now we need to check that out. Say for instance, all of them are basically I would say trigonal bipyramidal, like something like this. Okay, now for you can see clearly that in the gas phase, PCl5 exists as molecules. There are trigonal bipyramidal. The question is, which of the resulting molecules does not have a permanent dipole? Now, if we check A, what happens? Like, let's say, and let's say another thing, that two axial chlorine atoms are replaced before the three equatorial atoms. So, at first, these two will be replaced consecutively, and after that, the equatorial ones will be replaced. Now, let's say we replace this with an F. Now, obviously, this becomes what? This becomes asymmetrical, right? That means, why does it become asymmetrical? Because these will reinforce towards the phosphorus, will cancel out each other, but the F here will reinforce, I mean, the dipole will be reinforced towards, fluorine, because obviously fluorine is more electronegative than phosphorus, right? So as a result, one of the dipole will remain, and as a result, this will be asymmetrical. Okay? Which one? Oh, okay, wait. Chlorine has higher electronegativity, right? Compared to phosphorus. If it does, then it's this way. Yeah, then it's this way. I made a mistake. But this does not. If we replace this with F, then the dipole does not cancel out, because this time obviously it's gonna be this way. Oh, okay. I think I did the opposite. Like in phosphorus is a higher electronegativity compared to fluorine. Yes, I believe. Yes. So yeah, that is. Is it? Okay, 1 minute. I need to check the periodic table. Okay, I think I made a mistake. Actually, we do not analyze it according to electronegativity. It's just that you need to check out the asymmetricity and symmetricity, nothing else of the molecule. And I just saw in the book they give an example in something like this, where if you see clearly that if four of the bonds are identical, they just basically, the polarities just cancel out each other by reinforcing each other. Okay, so if the polarities cancel out each other, simply the molecule becomes non-polar. Actually, there is no, I mean, electronegativity is out of the question. I think I made a mistake. Now, the same thing happens here. Like, look, here they give hydrogen, so obviously the whole, not all of the polarities, cancel out each other. Like this one cancel out, but this one doesn't. So obviously this becomes a polar. I mean, the CH bond remains polar, so obviously the whole thing becomes a polar molecule. So something like this happens when you replace a chlorine, axial position chlorine with fluorine. Like what happens, you can clearly see these four will cancel out the polarities, but the pf1 will remain. So as a result, it will have a permanent dipole. And how will you understand the molecule have a permanent dipole? When you conclude that the molecule is polar. Any polar molecule will have a permanent dipole, right? So since this is polar, so this will have a permanent dipole, so that is out of the equation. If we see C and D, like, let's check out C and D. Okay, if we see PCl2F3, so at first, the first one is removed from here, then another one is removed, and if we see from the equatorial, another one, any one of them will be removed. Let's say this one. Okay, yeah, maybe yes, these two, like the axial position fluorines, might cancel out their polarities, but check this out, these won't. Like, you can clearly see the equatorial ones, the bonds which are present in the equatorial plane, they are not symmetrical. Okay, there are two chlorines and there is one fluorine. Okay, so what's going to happen is pretty simple. This one will, obviously, this one will have its dipoles remain, like the polarities won't cancel out each other. By polarities I mean to say the partial positive and negative charges, they won't cancel out each other, but these two will. See, one remains, so you can clearly say the overall molecule is what, polar, right? So obviously it will have a permanent dipole, so C is not the correct answer either. Let's go for, I mean, again, I think the same reason for D as well, because if you see clearly that another F is removed in D, I mean, I'm talking about PClF4, another F is removed. So again, even if the axial position ones, and even if these two gets, cancel out, this one remains, right? So this kind of makes, I mean, again, the main reason is that the equatorial bonds are not symmetrical, so that is why one of the polarity will remain. In this case, the PCl bonds polarities will remain. So as a result, the whole thing becomes polar. So it will have a permanent dipole. So the only answer is B. And why is that the case? If we see clearly what happens in B, what is happening in B? Like the axial position chlorine molecules are being just, uh, replaced while those chlorine remain. So yeah, it kind of makes sense. If you clearly see what is happening, both of the planes are having symmetrical bonds. Like both of them have the same bonds, right? It's the So basically the main point here is that you need to ensure that all the bonds within a plane remains symmetrical. Am I clear? If all of the bonds within a plane are symmetrical, only then the polarities will cancel out each other. Otherwise, one will remain. Rakshi, did you understand? Okay. It was a little bit tough. Okay. The next one you said, if I'm not wrong, question number 17. Uh, I believe this one, right? Okay, at first, what did they say here? Bromine water reacts with what? 2-methyl butene, isn't it? So if we see, if we draw 2-methyl butene, let's say something like this, 2-methyl. So here, this is 2-methyl butene. And then what is happening here? The I mean, if you draw the mechanism, what is happening? Uh, this is happening, right? This is happening. So that's the first step we know when it attacks, when the bromine molecule attacks. Now, what did they say here? They say, yeah, say anything. Yeah, okay. Yeah, what's the issue then? Oh, BROH. Sorry, sorry, I made a mistake. Yes, yes, I did the opposite. Yes. Now, you want to say something? Continue. Now, oh, why bromine will have the partially positive? I say, what's it called? Main thing you have to I mean, have you ever seen hydroxides being positive in your life? No, no, we are bromine. No, no, you must have seen bromines being positive. Bromine can be positive and it can be negative as well. I think you haven't you seen bromine being positive? There are many cases. Okay, either way, let me just tell you one thing why hydroxide is negative. Simply because this right here is an ionic solution. All right, so obviously you can understand this is going to be Br plus and that's going to be OH minus. That's it, nothing else. Okay, bromine water is basically an ionic solution. That's why. I mean, I maybe because we are confused because bromine water's formula has not been used in the book, right? Maybe because of that, isn't it? Okay, fine, no problem. But uh, right now, just understand that bromine water is an ionic solution, and we know and in an ionic solution, we know one has to be a cation, and another has to be an anion. All right, so something like this happens. Now, moving on, what happens is that again, they said here major product, right? Now we know major product is produced according to this, the stability of the carbocation. Now there is two way you can put I mean, you can two carbocations may be produced. You have one this way, another this way, like for instance one here, another one could be produced here. Right. If the bond is broken. Now we don't require the primary carbocation, right? So we will not use that because that's a minor product. We'll be requiring the major one, the major product. I mean, since they say that major product is produced, so obviously we'll check out the major one. So if this is produced, uh, what's going to happen? So the bromine gets attached since this is done, obviously, because we know that the partially positively charged gets attached while the negatively charged one attacks the carbocation. We all know that. You have seen in HBr as well, isn't it? This is positive and this is negative. Yes, I can understand. This is not an ionic solution. Like I think Rakshit, I understood your point. Maybe because this is a very weird compound. They've never, I think they've never used ionic solutions to show mechanisms in AS level. That's why I think you're confused. This was a little bit bit of an exception, but I think now you're familiar now that I've explained it. Mostly we have seen HBr or we have seen BRBR, something like this, right? Isn't it? Okay, that's why. So, anyways, what is happening is that it's pretty simple. Now, obviously, the OH is going to attack which one did, and eventually, I think the answer is A. BR is supposed to be on the sorry. You mean this one? I mean this one. Uh, Look, I'll be honest. First of all, how, I mean, why will it be in the second carbon? Please tell me. Like, why? Why do you think it will be in the second carbon? Look, I have to see. No, 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 no. This is not a secondary carbocation. This is where you guys are making a mistake. I think you can clearly see here. This carbon has one, two, three carbons attached with it. This is not a secondary carbocation. This is a third degree carbocation. Did you get it? And remember one thing that this is very important. If you know this trend, so obviously the third degree carbocation is more stable than 2 degree. So obviously instead of I mean, if the bromine gets connected here, I mean, look, I mean, let's try this. If the bromine gets connected here, second degree will be produced. But why will the second degree be produced if we have a more favorable condition for third degree to get produced? Because third degree is more stable than 2 degree, isn't it? We always want a more stable carbocation, right, for a major product. And if third degree is possible, then yes, third degree will be produced. Okay, did you guys understand? Anyone else? I mean, Rakshit, what I try to mean? Hello? I got disconnected for a while. Okay, what I was trying to say is that uh, you guys are familiar with third degree, second degree, 1 degree, right? Like, look, as Mohideen said, if the bromine is connected with this, then what's going? I mean, if the bromine is connected here, then we get to produce we get a third degree carbocation because you can clearly see the second one is connected with 3 carbon, and it is more favorable to produce a third degree carbocation because it's more stable than a second degree one. So in reality, I mean, so why will a second degree carbocation will be produced? I mean, if there is a possibility for third degree carbocation to be produced, then obviously third degree will be produced. Okay, that's the whole thing. So it is possible to produce a third degree carbocation. So that is why bromine gets attached to the third carbon. Okay, Mohideen, did you understand? Hello. Okay. All right. Fine. So next, I guess the answer is A. Yes, the answer is A. Anyways, let's move on. Uh, how what did you write? I didn't understand. How do you identify shape of compound with two central atoms? I think these are the questions, right, Rakshit? Okay, so what is the question? Can you please say? I can't understand the writing. How do you identify shape of compound with two carbon atoms? Or is it two central atoms? Okay, fine. Do you have an example? January 21. Okay, so it's kind of related. 1 minute, I need to check. This one. Uh, which molecule is planar? They said. Okay. I mean, we can say this is octahedral. We all know that. So that's cross. If you talk about PF5, then obviously it's going to be trigonal bipyramidal, considering there are five trigonal bipyramidal, right? So that's out. If you see between A and okay, this is tetrahedral. So most probably C2F4 will be the answer. Now, did you do the way how I did, or are you asking me that how will we understand whether a molecule is, like how will you understand the shape by seeing the two central atoms? I mean, if there are two central atoms, is it? Okay, C2F4. If we just draw it, C2F4. To be honest, there isn't any central atom here. Like, if you see here, right, there's no central atom here. And why they're saying it's a planar? I mean, mainly uh, because you can clearly see because it's, because it's one, I mean, all of the bonds, like if you see where both of the carbons, they're present in one plane, while all of them are present in this plane. So the fact, actually, to be honest, there are no central atoms in this molecule. Okay, so the reason why it's planar mainly because the I mean, it does not have an exact shape. It's just that this said planar because the bonds or the carbon, or if you say fluorine, they all, I mean, if you see CF bonds, they're all present in a vertical plane, while they're present in a, the carbons are present in a planar plane. I mean, this is also planar, this is also planar. It's just that this one is vertical and this one is horizontal. So yeah, that's in overall sense the molecule is a planar. Okay, like, did you understand? Maybe because you assume that C2F4 will have two central atoms. That's why, right? Yeah, maybe because of that. Yeah, actually, it does not have any central atom. Anyways, moving on to the next part. Uh, you said January 21, question number 21F. Question number 21F, the whole one. I believe this one, right? Uh, these were easy, I believe. What is the issue here? This one and this one. Okay. Okay, 1 minute. Anyways, state the number of geometric isomers. So they're trying to say how many. What was the answer that you got? What was written in the answer, Rakshit? No, no, no. I see four was, no, four was written. I can see the mark scheme there. There are four. Why four? I mean, if we see, okay, this is not possible. This is possible. This is not possible. This is possible. Yeah, so this is gonna have an E and Z, and this is going to have an E and Z. Yeah, four. Why did you understand? Because if you check out in this one, you can clearly see with one carbon, one of the carbon in the carbon to carbon double bond, two identical groups are attached. So yeah, that won't show geometric isomerism. If we see here, down here, again the same reason with one of the carbon consists of two hydrogen bond attached to it. So yeah, that's not possible. Yes. Do you understand why four? What? I didn't understand. Sorry. This one. What if I have the? Okay, fine. Next, complete the diagram to show another structural isomer of C50 and H24. Uh, like, fine. C15H24. I mean, this is C15H24. This is the structural formula. And, okay. So, according to MS, these are the bonds, basically. So, I mean, what they did down here was that they basically, you know, they did one thing. Like, basically, they just, took out the double bond. Like, the molecular formula remains the same. It's just that what they did down there, like, you can just give any of the structure. It's what they did down there is that they just, cut. three of the double bonds, and they just keep any one of the double bond. Like you can keep any one of the double bond, and then you can just change the position of the double bond, right? And just like draw the structural formula. Okay, you can ignore this. This is a little bit more complicated. Ignore this stuff. So any one of them, since it's 1 mark, so any one of them. So they have provided you different perspectives. Okay, so that's how it goes basically. Like, what do we know about isomers? They have the same molecular formula but different structural formula, isn't it? Right? So did you understand? I mean, C15H24, it remains the same. It's just that the structural formula is changing. Rakshit, did you understand? Okay, fine. Moving on to the next one. Okay, this is done. Question number 2, 11, 12, 16 AD. Question number 2, 11, 12, 16 AD. Same paper, right? What's wrong with question number 2? This is very easy. It's an MCQ. What's the issue in this one? Wait 1 minute. Let me just bring all of them. There are this much amount of atoms is 0.25 mole of what, right? Okay. Hmm. Okay. Like how you will approach this problem, isn't it? That's what you're trying to say. Like how will you do it, isn't it? Hmm. Okay. At first, we need to check out uh, which one contains the correct number of atoms per mole. Okay. We can clearly see for helium there is only what, like one atom. We can clearly see there's only one atom per formula. Like there's only just one atom, like one type of atom. If we see in water, we can see there are three atoms per molecule, isn't it? Three atoms per molecule, like two hydrogen plus one oxygen per molecule, isn't it? For this, I think it's obviously four atoms, like one bromine atom plus three hydrogen atom. All right, and yeah, that one's five atoms, obviously four hydrogen plus one carbon. Okay, fine. Okay, so first of all, if we see here the Avogadro's number, what does it mean? It means it represents what? It basically represents the number of particles in 1 mole of a substance, isn't it? Like that means 1 mole of a substance consists of 6.02 times 10 to the power 23 particles. Now, since we have 0.25 mole here, we are basically looking for a substance that would contain 6.02 10 to the power 23 atoms in 0.25 mole. So it basically means that the substance that means the substance must contain four atoms per molecule. Like if you see like 0.25 divided by 4, that's 1. Yeah, like because if you like if you see clearly that I mean, how does 1 mole come? I mean, it's only possible if the if the compound basically contains four atoms per molecule. I mean, by judging the mole, we can clearly see that if we multiply, then in order to get 1 mole, so we require at least four atoms per molecule. I mean, since if since it's given 0.25, so That means the answer is C. Yeah. Did you understand what I'm trying to say? Okay. 1 minute. Part. Uh, which of these does not have a structure formed by giant lattice carbon atoms? Hey, what is the I mean, this was very easy. Well, which part are you confused in this one? Rakshit? This is very simple, isn't it? I think this is C60 fullerene. And obviously, the answer for the next one will be HF. The most polar, considering what? Most polar is what? Electronegativity difference, isn't it? This one is the lowest, this one is the highest. Obviously, the electronegativity difference will be, you know, the highest. Yeah. I don't think there isn't any, I mean, there isn't any confusion for this type of topic, I mean, question. These are very simple. Like these three obviously have a giant covalent structure, but this does not. C60 fullerene, it does not. It has a simple molecular structure. Did you understand? Uh, can you hear me now? Hello? Okay, did you understand what I'm trying to say? I mean, what I'm trying to say is that here we can see why this is polar, because obviously hydrogen has the lowest electronegativity and fluorine is the highest. So obviously electronegativity difference is the highest here. That's why it's the most polar. And C60 fluorine, obviously, it has a simple molecular structure compared to compared to its counterparts, which have a giant covalent structure. So that's why. Anyways, moving on. The next thing you said, uh, uses of graphene. What are the uses of graphene? Like, where did you get this question? Uses of graphene? Like, you need it? Okay. There are lots of, you can say, uh, uses basically. I mean, you can use. Yeah, yeah. I know. I missed. I'll talk about it. I mean, uh, as far as I remember, graphene can be used for, this is a sensible answer for a 3 mark question if there is one. Like, how about this one? It is used for, it is used in flexible and fast electronic circuits because it conducts electricity very well. It is used in batteries and supercapacitors to store energy more efficiently. And it's also used in medicine for drug delivery. You can just write this three for a 3 mark question. Okay, and why does it conduct electricity? Same thing, it contains delocalized electrons. That's why. Okay, you can just copy this. All right. Which fuels or new resources are carbon neutral? I mean, there are lots of fuels. Like one example of a biofuel is what? Ethanol. Ethanol is obviously what? It's a biofuel, right? It is recyclable, and it does not, what's it called? It does not provide it does not impact carbon footprint, or it does not, contributes to carbon footprint. So yeah, that's one way you can. I mean, this is one example of a fuel which is carbon neutral. Okay, did you understand? Like there are lots of. Do you need more examples? Like, what do you mean by carbon neutral? It basically means that something which releases carbon dioxide, isn't it? Like, I mean, like what I'm trying to mean is that a fuel is carbon neutral if the carbon dioxide it releases when burned is balanced by let me show you the definition, then you'll understand what we understand by carbon neutral here. So, what is carbon neutral? Basically, a fuel is carbon neutral. Yes, didn't understand. Can you please say again? Hello, can you please say again? Can you please write it down? I think it got cut. Fossil fuels is not carbon neutral. They are not carbon neutral. Why? Because what is carbon neutral? Like if a fuel will be carbon neutral if the CO2 released when burned is balanced by the CO2 it absorbs from the atmosphere during its production. Like when the plants it was made from growing. All right. This means it does not increase the overall carbon dioxide levels in the atmosphere. Fossil fuels do not absorb it. So how is it carbon neutral? Like the amount of carbon dioxide it releases via complete combustion, it does not absorb it. So it is not carbon neutral. Do you understand? Hello. Okay. So what are some examples again? Some of the examples you can say is, like I said a little while back, ethanol, or you can bioethanol, whatever you say. Like for example, things which are made from sustainable renewable sources. Say for instance, bioethanol. Then you have biogas. Then there is another example, like for instance, biodiesel. These are examples of carbon neutral fuel. Why? Because these are produced like bioethanol is produced from plants like sugarcane or corn. Biodiesel is made from vegetable oils or animal fats. Biogas is made from the breakdown of organic waste like food or manure. So these all are recyclable. So yeah, plants from which they're made, they basically absorb the carbon dioxide, and that's why yeah, they are carbon neutral. Kind of, you can say. All right, the last question you said shapes of unfamiliar molecules, for example, 5 bonding pairs and 2 lone pairs. Is that it? Like, can you give me an example where you found 5 bonding pairs and 2 lone pair molecule? What do you mean by that? Mm, I mean, there are lots, to be honest. I mean, one could be, let's, a trigonal bipyramidal. I mean, it could be that. Uh, okay, let's take an example of iodine trichloride, as you said, ICl3. Now, how many outer shell electrons does iodine have? Can you tell me, if I'm not wrong? Rakshit, what is the electronic configuration of iodine? Uh, it's 53. Okay, so you can say like it's huge, to be honest. I believe uh, 5, 2, 6, 6. Okay, there are 6 electrons in its outer shell. This is very complicated. What you understand. Look, there are 6 electrons in its outer shell. So if there are 6 electrons in its outer shell, and there are 3 chlorine atoms, let's say chlorine, chlorine, chlorine. So like, yeah, you have this, you have that, you have that. So these 3 gone, and I believe 1, 2, 3, 4, 5. Is it 6 electrons? Oh no no, there's sorry, I made a mistake. There's 7 electrons. I made a mistake. Yeah, there's another electron down there. Yes. So yeah, here we go. You have three bonding pairs. So we have three bond pairs, and okay, wait, 1 minute. There are more electrons. 1 minute. Who joined? Why can't he join? Hello? Everywhere. Okay. So ICL3 is an example. Like in ICL3, what happens is that you have, you know, something like this. So what happens easily is that, so here we go, one, two, three, four. One, two, three, four. Hello? 1 minute. One, two, three, four. One, two, three. Okay, sorry. One, two, three, four. And this one has a double. Sorry, I made the mistake. Yeah, one, two, three. Yeah, sorry, I made a mistake. I saw it a little while back. Yeah, this weird molecule, maybe, but I don't know. I have never seen this in the ACE level. Where did you see it? Which question paper did you see? I mean, this is an example where you get 5 bonding pairs and 2 lone pairs. Rakshit, do you remember where you saw it? A long time back. Okay, I just used this is one example basically, but I believe you won't find so hard this sort of complicated stuff. Anyways, okay, fine, no problem. Okay, with that, I think your problem list is over. We'll move on to Mohideen's ones. All right, fine. Where is Mohideen's ones? Mohideen, you send the list on your WhatsApp, right? Okay, fine. These are the ones we can clearly see. January 24, question number 1, 15, and 22A. 1 minute. Okay, do you hear me? Check this out. Which element could be Y in an ionic compound with the formula YF2? If we see element P down here, okay, what was the answer of A and B? It was B and A, right? Like A and B's answer. Cynthia, Moideen, hello. Okay, did they give any? Okay, B and A. So B and A. So element P, we cannot take element P because that is a gaseous covalent compound, so that's out. We cannot choose element Q as well because we can never we cannot have an element with full outer shell of electrons. It's not possible to produce an ionic compound because obviously there's YF2, so that's not possible. Among R and S, if we see among R and S, if you see with R and S, this one's ionization energy is higher. Why it's ionization energy? Okay, it most probably it's element S. Why it's not element R? Like both of them has equal chance of ionic compound, but since it's low, there is high chance YF may be produced, not YF2. Okay, uh, because in order to produce YF2, you need to take two electrons out, right? So obviously more energy will be required. So yes, S will be the most correct, most possible answer is S. If we see the next one, D down there, uh, which element has atoms with the largest atomic radius? Largest atomic radius basically means what? The electron must be I mean the if we see among the four, who has the lowest ionization energy? Obviously element R, right? That means the first electron being removed is obviously farthest away from the nucleus, so obviously force of attraction will be low, so less energy will be required to overcome it, so that is why it has the lowest ionization energy. So yes, element R is the answer. Did you understand this? True. Okay, which statement about polyethylene is not correct? That's it. Okay. Uh, if we see in this one down here, is not correct. They say it is an addition polymer. Yeah, it is an addition polymer because it is produced from addition polymerization. So that is correct. Polymers are non-biodegradable. That is also correct. It has the empirical formula CH2. Does it? C2H4. No, no, no. Wait 1 minute. I mean, yeah, C2H4. So yeah, it does have empirical formula. Most probably B is not the correct answer, basically. Yeah. Uh, Rakshit, I didn't understand. What did you say? Hello? What, isn't that for, oh, isn't that for one subunit? Yes, 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 it is for one subunit. Yes. One subunit. Yes, yes, yes. A repeat unit. Like a lot of your repeat units create the polyethylene, right? So eventually, what's going to happen? Yeah, I mean, if you draw it this way, I mean, if somebody tells you to write the empirical formula, what will be the empirical formula? Something like this, right? So yeah, it kind of makes sense. It is correct. Yeah, the only answer is B. It doesn't decolorize bromine water. Why it doesn't decolorize bromine water? Because it does not have a double bond. The polymer has infinite units. I get the point. Infinite units is in the fact that it has a lot of repeat units. Yeah, that's what I'm trying to mean, right? But main thing is that they basically told here that what is the empirical formula, right? If they tell you to find I mean, in other words, they're telling they basically told to find the empirical formula for repeat unit. Okay, because the how do we identify or recognize a polymer? By according to its repeat unit, isn't it? So yeah, in one way it is correct. And obviously B will not be correct because yeah, it does not have the double bond, so how will it decolorize flow in water? Right? So Mohideen, did you understand? Okay, what's wrong with number 22? Please tell me. Like, which part of it you did not understand? The whole thing. What is the issue here? Okay, it was given. Okay, okay. Gram per dm cube is provided, and you are provided. So we need to convert the dm cube to meter cube. Like I said, in PV is equal to nRT formula, you need to convert everything to SI unit, isn't it? So meter cube you need to convert, and you also need to convert 20 degrees Celsius into Kelvin. So to at first convert it, 28 plus 273, 293 Kelvin gone. Then let's rearrange the ideal equation. PV is equal to RT. We need to find the number of moles. Gone. Anything else that we need to see? Okay, they said the density of an unknown gas is 0.656 gram per dm cube. Right. So per dm cube basically means that the volume is, I mean, in this case, the volume is 1. And if you want to convert dm cube to meter cube, so you just divide it by 1000. So that's what, 1.0 times 10 to the power minus 3. What I did, I just took it into 10 to the cube and I picked it up. I think you understood. I converted this. I converted this. Now I just place it everywhere. I mean, just place all the values. 101,000 times volume is obviously 1.0 times 10 to the power minus 3. And then you have 8.31, and temperature is you got 293. Eventually I believe you will get about what, 0.04 something, 0.044148 mole. So that's the number of mole. Now you need to know the molar mass, right? And you need to know the molar mass, they say. And you have 0.656 gram dm cube per dm cube. So if you just divide it with this mole, 0.04148 mole. So 1 minute, let me think about it. We know density is equal to mass by volume. So uh, you know what's mass. You can just write as that molar mass times mole. Okay. Yeah. Okay. Makes sense. Yeah, it makes sense. So if you want to make the molar mass the subject, so if you just make it down, density divided by times volume. Uh, yeah. Okay, times volume divided by mole. I just made mole mass the subject. Now I think we know everything. We know the density, which is what, 0.656 times. We also know the volume, which is obviously 1 dm cube. So gram per dm cube times 1 dm cube divided by mole is how much? 0.04148 mole. So yeah, so not dm cube, just dm cube. Now what happens is that if you just take this below, so 656 gram per dm cube divided by 0.04148 mole times per dm cube. So if you just cut this out, eventually you get something like if you divide these two, whatever you get, like look, if you just take this mole above, eventually you get what? I don't know what's the value if you divide it, but eventually you get gram per mole, which is the molar mass formula. I mean, unit. Did you understand, Cynthia? How I found it out? Okay. Fine. Sure. Yeah, yeah. Okay. Rakshit, fine. Very good. All right. The next one is 23, 19, 14, and 20. June 23. Nineteen C1. This two, right? Is it okay? Okay, they said here what? They said here to complete the table to show the ions responsible for these peaks. Well, these are just combinations. You just need to find combination, isn't it? Uh, what can you do? Like there are this is what like PCl3, right? So there are three, you know, elements being involved. So how will you do the summation? Uh, Phosphorus is only one isotope, but we know chlorine has 35, another has there is 37, right? So 31 phosphorus, then what? 35 chlorine, 35 chlorine plus, yeah, so 35, 35, 31, yeah, it brings 101. So all you do is just do the combinations and check whether 103 or 101 comes or not. So for the same thing, 31p, 35 Cl, I believe this is with 37 Cl plus, and anything else? Oh yeah, the now last one will be obviously 31p, 35 Cl, so actually 37, 37, 37 Cl plus. It's just basically combinations, okay? Nothing else. Very simple. Okay, they said here show that the relative peak height given height peak heights given in the table are consistent with the isotopic ratio of chlorine 35 to chlorine 37 being 3:1. Like you just need to show the data. So we just need to find the ratios of the three ions somehow. So for 101, if we see, what do we have here? We have 35 chlorine and 37. So we just need to see the abundance here. Now we know that I mean, It's given in the book. I mean, even if you don't find it here, like, I mean, it's not there though, but maybe it's there in A, A and B. Maybe, I'm not sure. Maybe it might be there. But as far as I remember, chlorine has yeah, chlorine 35 has 75% abundance, and chlorine 37 has a 25% abundance. So that's like 3/4, and this is 1/4. So for the first combination, all you do is just multiply the you know mass to charge ratio with the abundances of each. So 3/4 times 3/4, what do we get? We get 9 by, I mean, for 101 you get 9 by 16. Then for 103 one, I think there are 35 and 37, so that's 3/4 and 1 by 4. So that's 3/4 and 1 by 4. If we see, that's 3 by 16, I believe. Yeah, and that's 105, 1 by 4th and 1 by 4th, since 37, 37. So yeah, that's 1 by 16. 35 is to 37. So if you find the ratio, 1 minute. I mean, the ratios are, I mean, if you see, I mean, what they're trying to say here, whether it's 3 is to 1 or not, like the peak heights, it has to be 961. The numerators has to be 961 somehow. Then we can understand. Maybe I'm missing something. Uh, okay, yeah, that makes sense. I mean, uh, yeah, it must be multiplied with 2 because we don't know whether the combination is 35 Cl, 37 Cl minus, or sorry, Cl plus, or is it 31 P 37 Cl 35. So we don't actually know which way it is happening. So yeah, it must be multiplied with 2. Eventually you get 6. So yeah, if you find the ratio, you will see, I mean, if you just find this one's ratio, I mean, if the 16 gets cut, it is 9x to 6 is to 1, which is consistent with the peak heights. Okay, yeah, makes sense. What I mean to say, I mean, okay, did you understand? Like, yeah, I mean, I 3 by 4, 1 by 4, it kind of comes from this ratio. All right. But I mean, how does this ratio comes? This ratio comes from the percentage abundances available in the nature, chlorine 35 and chlorine 37. Mohitin, did you understand? Okay. January 23, the 14 and 20. Which molecule is polar? They said. Okay. We also, how do we determine polarity? We basically determine polarity by checking the symmetricity and the asymmetricity of a compound, isn't it? Because if it's symmetrical, then the dipoles are cancelled. If it's not symmetrical, the dipoles are not cancelled. So 1,1 dibromo propane. And then you have E 1 pro dibromo ethene. So this is symmetrical because you can clearly see they cancel out each other and that cancels out each other. So that's not polar. If I talk about tetrachloromethane, so that's Cl, 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 Cl for you. Yeah, this is not polar either. Uh, if I talk about hexafluoroethane, uh, hexafluoroethane, something like this, right? Again, this is a symmetrical molecule, so it kind of cancel all the dipoles cancel out each other. So we can clearly say that that's not the correct answer. The only correct answer is A, and it kind of makes sense because if you see that these two, the dipoles will remain, although the others will cancel out each other, but these two will remain because it's asymmetrical. As a result, the whole molecule becomes polar. Okay, I hope you understood. This is very simple. Which molecule can exist as an EZ isomerism? Now, for sorry, Rakshit, the bromines are supposed to be on the same C. Okay, yeah, yes, they're supposed to be on the same C. Yeah, 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 yes, yeah, I made a mistake. Anyways, which molecule can exist as EZ isomer? Okay, for EZ isomerism to happen, at first we need to check out whether the let's talk about hex 3 in first. Hex 3 in, so it's somewhere here. All right, so you have 2 chloro, 3 4 ethyl. Okay, and the rest is hydrogen, right? I believe. So this is not possible. As you can clearly see, this one and this one, like CH3, if we do it, CH2, these two are identical. Like you can clearly see these two are identical. So A is not possible. Yeah, tell me. Ask. You want to say something, Moidin? The bromine becomes? Yes, Moidin? No, no, no. How will it cancel? I mean, look, they're in the first carbon, right? Yes, they will cancel out each other, but there is no bromine here and there is no bromine there, right? So this one won't cancel out each other, this will remain. Did you understand? All of them has to be identical, only then, like, they can, you know what's it called, like, cancel out each other. So this one will remain, so that is why it is polar. Okay, I hope you understood. What do you mean by that? They are in the set, even though they're in different cases. You have to see one thing, that okay, what does E mean? E basically means, E means opposite, right? Or same, or in the same sense. Okay, 1 minute. uh 1 minute, 1 minute. Okay, I think, let me tell you from the first. In this type of questions, I mean, uh, how will you determine the asymmetricity, isn't it? That's what you guys are trying to say. Wait, what happened? Look, if bromine is connected to the same atom, all right, then it will create an asymmetrical structure. Okay, but if bromine, or if if bromine is connected to two different carbon atoms, like for instance somewhere here, like you can clearly see this is connected to two different carbon atoms, and both of them are on the opposite side, then we will consider it is symmetrical. Okay, am I clear? I mean, this one was a little bit complicated, a little bit an exception, basically. Did you understand? I mean, I don't have to explain C and D, but for A and B, I think the confusion was there, wasn't it? Okay. Hello, Moidin. Okay, fine. Just remember this, basically. Okay, as I was there, so this is not possible. Is B possible? Rakshit, tell me whether B is possible or not. Judge, tell me. And why it's not possible, tell me. Rakshit, can you hear me? Look, why is it not possible? Now what is happening? 3 chloro 2 methyl. Right, so 3 chloro, 1, 2, 3, 3 chloro, uh, 2 methyl. So 2 methyl, hex 2 in, I believe. So that's gone. I'm also sorry, 1 minute. Oh, hex 2 in, they said. So here, 2, 3, 4, 5, 6, 1, 2, 3 chloro, 3 chloro, second one, uh, this one's CH2, Yeah. Okay, it's not possible because you can see in this carbon you have two identical, so that's not correct. 2,3 dimethyl hex 2N. 2,3 dimethyl hex 2N. If we see uh, hex 2N here, so 2,3 dimethyl. So here one and here one. Okay, it's definitely not possible because you. Is it possible? No, it's not possible because again identical. So the only answer is D. I don't have to say. I mean, I don't have to show how is it D. But since the three options are not, so D is the correct answer. But did you understand how you approach this question, Moidin? All right. That's done. Now 24, 19, 12, 15. This one. This is 15, I believe. C3. Uh, there is no C3. There is C2. Mohideen, did you make a mistake? There is no C3 of 15. Is it C2? Please tell me. Okay, I think this list will be over if we finish these all. Uh, First question, let's go. You have this one. Compare polar and non-polar liquids. A stream of liquid from a burette and a positively charged plastic rod was taken. Okay. Okay, fine. Which row of the table shows the correct direction of the deflection? Direction of the deflection. polar liquid towards the rod. First of all, yeah, it is possible. Non-polar liquid away from the rod. Okay, first of all, what's it called? Non-polar liquids are not deflected. I mean, they don't even experience any deflection since they're not charged. So that's just gonna fall. I mean, they're not going away or anything. They will just basically drop as it is like this. So that's not correct. Polar liquid, why will it go away from the rod? It should go towards the rod, so that's B gone. Yes, this is correct. No deflection. Yeah, this is the viable answer. If we see, no, this is not correct because obviously polar liquids experience deflection, so C is the correct answer. Yeah, did you understand? Towards the rod because polar liquids are charged, that's why. Polar liquids are charged. Don't you know that positive means charged? Say for instance, this is a polar molecule, and it does contain charges, so it is charged. So now the question is, you don't know whether the polar molecule is negatively charged or positively charged. We don't know that, do we? But what we do know is that it is charged, isn't it? So if it's charged, let's say, I mean, it also can, I mean, since it's charged, it basically contains positive and negative. So maybe the negatively charged, you know, does it? It attracts. It gets attracted towards the positively charged rod. Did you understand? Hello? Okay. Which pair of compounds will not react to form a precipitate? Uh, okay. Not react to form a precipitate. Uh, well, this will react to produce, we all know, AgCl. So that's out. Yeah, obviously, CaCO3. Yes, that's out. I mean, that's V is going to be. Now, this might not. BaCl2 is not a precipitate. I mean, not necessarily, it's not a precipitate, basically. Will this? Yeah, PBI. It might. This is a precipitate solid. Yeah, C is the answer. Okay, did you understand? Y12? Okay. Uh, Silver chloride decomposes in light. Reaction was used in the first photographic plates. Write an equation for the decomposition. What is the wrong, answer? I mean, what is the issue here? Tell me. Oh, not A. B, Roman one. Okay. When copper metal is added to silver nitrate solution. Okay, what is happening here? Copper and silver nitrate. What's it called? Silver nitrate. What is happening? So, a yeah. So CuNO3. I mean CuNO3 2 plus Ag is produced. So what is happening? Blue is going to what? Colorless. Considering copper's blue color is gone because copper has now reacted. Or wait, did I make a mistake? I think I made a mistake. 1 minute. Hmm. Okay, okay, yeah, yeah, yeah. Made a mistake. Sorry. I just wrote it the opposite. Colorless. This is solid, right? We're basically adding solid to silver night. So eventually it was colorless before, and then it turned blue due to copper. And also another observation, we can see a gray solid is produced. So we can say gray solid and colorless to blue. Did you understand? No, silver does not has any color. So yeah, it doesn't. No color of silver. We can't see it. It's just plain like water. All right, moving on to the next one. Is it this number two? This one? This one, right? This is. Can you please tell me which number is it? I forgot. I believe it is 15B1 gone. C3, isn't it? C3, right? No, I mean C2. Okay, explain why copper makes the silver less malleable. Okay, first of all, how do you make something malleable? If the if the layers of atoms slide over each other, so the only possible reason we can say is that the layers of atoms in an alloy slide less over each other, isn't it? So that is why the malleability decreases. Now, why does it happen? Simply because copper atoms are smaller than silver. Because copper atoms are smaller than silver. I think everyone is familiar with the alloy structure, isn't it? What happens in alloy structure? Boom. Boom. So this is an example of an alloy structure. I mean, wait 1 minute. Let me show you very nicely. This is a big one. So imagine this is a silver. Imagine this is silver, and that's copper. All right, that's copper. So this is an alloy structure. So the thing is, since one is big, one is small, the sliding becomes very tough. The layers become, it becomes very tough for the layers to slide over each other. All right, so that is why the malleability increases. Did you understand what I'm trying to say, Moidin? Look, like this, they cannot slide. Sorry? Yeah, yeah. Copper is smaller than silver. Yes, yes, it is. Yes, copper is smaller than silver. Copper. Oh, the reason is it has a higher atomic, I mean, lower atomic number compared to silver. That's why. I mean, check out the molar mass of silver and copper. Who has the highest? Silver, right? So that's why. Do you understand? The size is determined according to the molar mass. Okay. Okay, fine. Gone. Everything. Okay, the next one is number 17A. Complete the dot and cross diagram. What is the mistake here? This is very easy. Which part are you confused? Tell me. This is very easy. Any issue? What is the issue here? I don't understand. Here you go. Right, we know what carbon is what 6, right? So what's that's wait 2 4. So that's 4 gone, right? Yeah, okay. And then again, we know what happens. Another, I mean, you don't have to show, but you just have to show it like this. I mean, you don't have to draw the other carbons, but that's how it works, isn't it? Like, uh, that's carbon for you, I believe. So that carbon is this. So I think I showed these four, this one, and now I want to shoot this. Now if I want to show again this, so this one I showed here, then this one I showed there, this one I showed there, and again, I mean, this one's I showed another carbon is attached with this. So yeah, this one I showed there. Okay, do you understand? I mean, you don't have to expand it because there's no more space, but I guess you get the point. Did you understand? It's like, what can I say? It's a part of it. It's like a photograph of a big tetrahedral unit, a small part of a big tetrahedral unit. Did you understand? Okay. Draw a labeled 3D structure of graphite. I mean, what is the this is very simple, isn't it? Like this how you draw it. I mean, graphite is a layered structure. You didn't know? I mean, this is the which part you which carbon to which carbon. I mean, as from every carbon basically, just from every carbon. Okay, from every carbon. That's it. Nothing else. This is the force of it. It doesn't matter. You just have to show that there is a force of attraction between the two layers of graphite. That's it. Another one is that suggest why diamond is a greater density than graphite. Well, what could it be? Like, come on, diamond, all the carbons are bonded to each other. I mean, there are no gaps, right? I mean, there are no layers. But graphite has layers. Like, the layers are farther apart. Like, there is a space here. You can see that, right? But do we have any space in the case of a tetrahedral unit of diamond? No, right? Isn't it? So if there is less space, that means there is less volume, right? We know what density is equal to mass by volume. Diamond has less volume, that's why its density is greater. Do you understand? Compared to graphite, which is more volume, so that's why its density is lower. Did you understand? Okay, I think 18. Which one? 18 2. A2. Suggest why neutralization does not occur in an unopened container of a baking powder. I mean, there are many suggestions you might say. Uh, Okay, what might happen if a container remains unopened? The baking powder may become dry, isn't it? Right? So if the baking powder becomes dry, it won't be effective enough to, initiate the neutralization reaction. Because when baking powders are dry, they get deteriorated. So yeah, this is the reason why it doesn't happen, basically. Okay, moving on, the last two questions. What is the issue with this? Tell me. Moedin, which part you did not understand? The math. Fast. Tell me. Hello. Tell me, Moedin, which part you did not understand? Do I have to show the whole one? Or what is the issue here? Hello. A Roman 2. I showed A Roman 2. I showed 18 A Roman 2. Then you said what? B Roman 3. Hello. Right. B Roman 3. So which part of it you did not understand? Do I have to show the whole one? I think we saw this a similar question a little while back, isn't it? Right? I think this is simple. I mean, this math is very simple, to be honest. What part of it I don't know you understood. You didn't understand. I think you are having issue related to maths, but these maths are very simple. Look, what is happening? You calculate the mass. They told you to calculate the maximum volume, right? So evaluation is what? You need to find V. So at first you calculate the mass. How can you calculate? You know the moles. You know the molar mass. So you just do that. 2 and 3. So why did you give 4? B Roman 2 and 3. This one. Write the equation for the neutralization of sodium hydrogen carbonate. So what is happening in a so this is the reaction, if I'm not wrong. I saw this in the MS. Okay. So what is happening here is that the the equation for the neutralization reaction is this, like uh, what is happening, the sodium hydrogen carbonate is going to react with H plus and with H plus K plus A2 minus. These two will be the reactants, okay? And then what's going to happen, the sodium is just going to replace the H and produce NaK plus and A2 minus. Now we know, since there is a carbonate, we have to carbon dioxide will be must produced, and obviously, since the hydrogen is replaced, and then carbonate, I mean, we all always know that during neutralization water must be produced. So yeah, that is why water is produced, okay? So this is the reaction for neutralization reaction, and carbon dioxide is produced just because there is the presence of carbonate, nothing else. So always remember one thing, that whenever carbonate compounds are there, carbon dioxide will be there as an additional product. Okay, with this our problem is done. Best of luck for the exam. See you. Okay, Simra, as far as I remember, you have sent me these problems here to discuss. Okay, these two questions are from January 25 as per your problem list. Uh, okay, in order to solve this type of question, at first we need to check out, I mean, let's try to find the number of moles since we have the volume and the concentration provided. So we know that concentration is equal to mole divided by volume. So we know the volume and the concentration. We can easily find the mole, which would be 0.050 times 40, obviously divided by 1000 to convert it into dm cube. So eventually, what you get is about 0.002 mole. 0.002 mole. Okay, fine. Now let's try to analyze this one. MgNO32. So when we, when we do, what happens in the solution? Well, the whole thing dissociates into Mg2 plus and 2NO3 minus. So in total, how many ions do we have here? Actually, we basically have three ions in total, two nitrate and one magnesium. So total, three ions are there. So they're basically telling you how many moles of ions are there in this solution. So since we know per solution, I mean per solution contains three ions. So what will be, and since per solution basically represents 0.002 mole, so if we just multiply it, we'll be able to get the number of moles of ions. So 3 times 0.002 will eventually provide you 0.006. Okay, and that would be our correct answer. Now, moving on, they say a water molecule containing the isotopes of hydrogen and oxygen, hydrogen 1 and oxygen, has a mass of this much, all right? Now, what is the mass of an atomic mass unit measured in grams? Let us just first find the atomic mass units using AMU of water. So, water, we know it's H2O, so it'll be 2, 1.0080. We're just using the data values provided, to find atomic mass units. So that would be, in my point of view, it is about 18.001 AMU. Okay, now they've already provided you the actual mass, which is about 2.9908 times 10 to the negative 23. So they told you to basically find the mass of 1 AMU in grams. So what does it say? What is the mass of an atomic mass unit measured in grams? So the mass of 1 AMU would be, if we just divide this with this, 2.9, like we know that 2.9008, now since this mass basically represents this amount of AMUs, so, or in other words, if we say this mass, this amount of AMU represents this amount of this amount of mass in grams, so what will one AMU represent? So we basically just divide it and we get the value, which would be uh, if we just do it, eventually we'll be getting 1.6605 times 10 to the minus 24 gram. That's C. Okay, number January 23. Which molecule is polar? You said this. Now, we know polarity of a molecule basically depends on the symmetricity or the asymmetricity of a molecule. Now, if you see clearly down here, what is happening? Bromine is connected to the same carbon in this one, okay? And if we see in 1,2-dibromoethane, what is happening here that both of the bromine are present since it's E, so both of them are present in, different sides of the plane of the carbon-to-carbon double bond plane. Now, obviously, this is symmetrical. If they were present, this is symmetrical, and this is also symmetrical. Now, if they would have, if the bromine atoms would have been connected on the same carbon, then obviously, E isomerism would not be possible, as well as it would not have been symmetrical. Like for instance, if it was something like this, if it was something like this, no, this is asymmetrical. Now, since this is obviously, I mean, this would be symmetrical basically. So we know that if something is asymmetrical, then what happens is that the compound becomes polar because one of them remains. Like for instance, this two will cancel out, cancel out their polarities, while the CH bonds polarity would remain. As a result, there's a high possibility that this might be, polar. And if I talk about hexafluoroethane, so we have this hexafluoroethane. I think you can clearly see the whole thing is symmetrical. So yeah, that is not this non-polar. That's also non-polar considering all of the identical atoms are connected to the carbon, the central carbon atom. So that's gone, and this is also gone considering the two bromine atoms. This is non-polar considering both of these bromine atoms are present on the opposite side. Plus, they're connected on two different carbons. Now, if they had been, if they had been in the now if they had been on the same side though, then it would have not been symmetrical. So now this is a little bit of exception, maybe not. I mean, this is an exceptional question basically, maybe because maybe you would not be able to see this type of questions, frequently in AS. But this is a little bit complex. But always remember that if bromine is present on the same side, or if any halogen is present on the same side, something like this, then we consider it asymmetrical. But if it's in this case, then it's symmetrical. So this is non-polar. So the only thing that's left is A is the correct answer. Now, which is the use of graphene based on its electrical properties? Now, you need to know drill tips are not used. I mean, drill tips are not used. I mean, graphene is not used to produce drill tips. Actually, diamond is used because diamonds do have sharp edges. For pencils, we always know it would be graphite, so that's gone, that's gone. Touchscreen is a possibility, but if we see body armor, no, body armors, yeah, we use graphene for body armor, but it's just that, graphene's, but I mean, we basically use graphene for body armor, but it's not based on its electrical properties. It is based on its, body strength or tensile properties. So that's out of the only answer is C, touchscreens. And it kind of makes sense because if you see how a touchscreen works, when you basically, put a finger or a spot on a part of your touchscreen, what happens is a lot of electrical charges gather in that point, and then they again, spread out and move on to the wires, and this basically takes the input from your finger and shows the output on your screen. So that's how graphene is used in touchscreens. And the last one, which you said, May 2023, which has the smallest ionic radius. Now we know smallest ionic radius means what? uh, Obviously, without any doubt, it must be a cation. So obviously, D and A will be cut, considering they're gaining electrons. So obviously, due to the increased repulsion, they will obviously have higher ionic radius. So this is just B and C. Now we can clearly see it out that compared to Na plus, Mg basically loses 2 electrons. So obviously, since it loses 2 electrons, the remaining electrons basically, what happens? The force of attraction between the remaining electrons increases between the already existing nuclear charge. So yeah, this will have the smallest ionic radius compared to Na plus. So B is the correct answer. Okay. I hope you have been familiar with all these types of MCQs. With that, we're done. And best of luck for the exam. Bye bye.